Karibu SolidWorks Tanzania. This is presentation number 3 on industrial automation PLC controllers. I hope you have enjoyed the previous lessons ambazo tuliangalia introduction to a PLC controller, lakini pia in the second presentation tuliangalia major types of a PLC controller. Tuliangalia modular na compact PLC. Okay, so in this one, we are going to dive deep on the central processing unit, as a CPU of a PLC. Tuelewe a CPU of a PLC, which is the brain of our PLC controller, ina nini haswa ndani yake. So this is the layout of a PLC CPU. So a PLC CPU has registers, it has a control unit, it has an arithmetic logic unit, it has a memory, it can either be random access memory or ROM or EEPROM, and it has something called a watchdog timer. These are inside a CPU of a PLC. So let's see one by one. So we said earlier, and we have said it again, a CPU is the brain of your PLC. It processes the inputs and executes the control program, then generates the output to drive the automation. Kwamba inapokea signal kutoka kwenye input, labda ni sensor ama ni switch, alafu inatumia ile program ambayo umeipa ku execute a logic, kutuma signal ambazo zita control the outputs, ambazo outputs zinakuwa ni actuators kama vile motors, relays, etc. So a CPU ensures real-time operation of machines and systems, right? So what's the function of the CPU generally in a PLC? Cha kwanza kabisa is to fetch, decode, execute cycle, right? Fetch, decode, and execute cycle. So it reads and executes the instructions, right? Secondly is input processing, kwamba tunajua CPU inakuwa iko connected na input interface, output interface, communication interface, memory and program and data memory, a power supply, a programming device, etc. So it has to process the inputs ambazo ni reads of data reads kutoka kwenye sensors ambazo zinapokelewa through the input interface. Lakini pia a CPU has to perform a logic execution, kwamba kulingana na ladder logic ulioipa, kwamba umeielekeza, maybe let's say we have an entry sensor at the conveyor and then we have an exit sensor at the conveyor. So umeiambia, if you see a box at the entry sensor, please start the conveyor. If you see the box exiting through the exit sensor, please stop the conveyor. So inakuwa inatumia hiyo logic kufanya maamuzi ya nini kifanyike kwa wakati ambapo the system is running. So it has to control the output, kwamba ina send control signals to actuators and devices. Kwa mfano, start the motor, stop the motor, start the light, stop the light, start the warning alarm, stop the warning alarm. Hizo ni control signals ambazo CPU inatuma kulingana na logic ambayo iko built in ama ambayo iko downloaded into your PLC. It has to perform also communication. Hii hapa kwamba CPU ina interface with the external devices kama Modbus, Profibus, Ethernet. Hizi ni network protocols, right? Ama IP. And then we have diagnosis and fault handling. Kwa hiyo CPU lazima pia ifanye diagnosis, inaweza ikajicheck alafu ikaangalia kama kuna any errors, ina monitor status ya operations and ina handle pia hizo errors. Lakini CPU has to perform a memory management, kwamba it has to store user programs and system configurations, right? Kwamba inputs zilikuwa connected where, outputs zilikuwa connected where. So how is the system configured? It has to keep that in memory, right? And what does the program look like? It has to store that. Hata kama kukiwa kuna power outage ama nini, it has to keep the memory for the stored programs, as well as it's running OS, operating system. Right, so let's dive in now to the component of a PLC CPU. First, we have the control unit right here. So this control unit right here, yenyewe it directs the operations and manages the executions. Kwamba kulingana na ile program ambayo iko stored kwenye CPU, control unit yenyewe ina direct what operations, what steps should be done after what happened. So ina manage execution of the program. And then we have the arithmetic logic unit. So arithmetic logic unit yenyewe ina perform calculations and logical operations. Kwa mfano, tutaangalia baadaye kidogo kwenye digital electronics kuhusu logic gates, kwamba we know we have variety of logic gates. Let's say tuna AND gate, tuna OR gate, and we know their principles of operation. Kwamba ukiwa na AND gate, that means if you have two inputs, then both inputs must be switched on so that you have an output. Okay, you have, so tunajua kwenye logic gates tuna binary operations like either a0 or a1, a0 for off, a1 for on. So tukiwa na AND gate, tukiwa na input A na B na output C, that means A must be high and B must be high for C to be high. So unaona hiyo logic hapo inafanywa na huyu arithmetic logic unit, ndo ana perform hizo logic operations na calculations. And then we have memory. So we see we have variety of memory kinds here. We have RAM, we have ROM, and EEPROM. So normally a memory stores the programs and process the data. Stores the programs and process data. A random access memory, a ROM is for the OS of your CPU. An EEPROM, this is where your program goes to. Ile program ambayo umeiandika kwenye laptop yako ama kwenye PC, unavoi download kwenda kwenye PLC, ikienda kwenye CPU inakaa kwenye EEPROM. Random access memory, more or less ina keep temporary datas. Okay, then we have a register. So a registers zenyewe zina hold temporary data for processing. So kunapotokea hizi kwenye PLC kwenye ladder logic wakati tunafanya execution of logics kunakuwaga na some inputs ambazo tunazi keep temporarily, and after a certain execution has happened tunazi reset, right? So kwa mfano inaweza ikawa labda okay, you are saying if start button is pressed, you have to store register that memory, right, as a high. Let's say memory unaipa labda number labda seme sababu hapa kwenye registers tunakuwa tuna tuna MW na MD. Hizo memory sections zenyewe zinatofautiana data pack. An M stores 8 bit, MW stores 16 bits, alafu MD stores 32 bits. So if you have an M for start, so if you store okay, the push button of start is pressed, store it on M 0.0. That means if you are resetting it, let's say if you press stop button, send a reset to the memory, to the register ambayo ni M0.0. So unatembea na kumbukumbu fulani kwamba okay, kuna button fulani ilibonyezwa, start button ilibonyezwa, so keep that in memory, lakini keep it in memory unless you have pressed the stop button, then reset the memory, forget that happened. So inakuwa ni ina hold temporary data for processing. And then we have a clock. So a clock actually synchronizes the operations and ensures timing accuracy. Okay? Kwamba kama ulisema let's say kwenye system yako labda kuna some delays, kuna some triggers and stuff like that. So a clock is there to make sure kwamba hizi action and events zinatokea exactly at the time that is needed. Kwa mfano umesema if I press the start button and I have a delay timer delay, let's say 1 second. So I press start button, it has to delay for exactly 1 second before giving an output. So a clock is there to ensure that the timing is accurate. And then we have a watchdog timer. So a watchdog timer is there actually to detect faults and prevent system failures. Okay, kama kwenye programu yako ambayo umeandika kuna sehemu ambapo kuna faults, ukiinstall kwenye PLC CPU yako, hii Watchdog Timer itakuletea error codes of what's happening. Maybe kuna sehemu ambapo actions zina interfere, zinaingiliana, ama has this happened at the same time, ama they are not happening as supposed to be. So a Watchdog Timer is there for safety of your CPU operations, kwamba inakuletea zile error signals ama error information and prevent the system failures. So we have something called CPU operating cycle ama scan cycle. Nadhani nilisema hiyo before kwamba inaangalia ina keep looking over and over again, very fast speed in milliseconds, to make sure kwamba every step is being taken as supposed to be at the right time. So ina keep looking on what should be done and has it been done yet, right? Inaangalia from input, kama input imetumwa, has it been executed by the CPU? Kama it has been executed by the CPU, has the data been sent to control the output? So it keeps on looking over and over again. So a PLC CPU follows a continuous scan cycle which goes as, first inaanza na input scan. So ikifanya input scan ina read input signals from sensors and field devices. Inaangalia, has the sensor sent any signal? Has the field device being actuated? Kwa mfano, is the switch pressed? Is the push button pushed or not? And then it goes to the program execution. So the cycle starts from the input scan, then it goes to the program execution, kwamba are the ladder logics or structured text executed? Has it been done? Kwamba okay, receive input imefika kwenye CPU, has the action been taken in consideration to the input that has been supplied? And then it goes to the output scan, kwamba okay, we had an input, we executed a ladder logic. Has the data been sent or the signal been sent to the actuators, to the motors, to the relays? And then it does a housekeeping. So housekeeping is like in update diagnostics, kwamba okay, I think kuna errors here and there, ama kuna faults, and then ina check pia the memory, pia ina check if the communication is okay. So normally the scan time depends on CPU speed and program complexity, typically in milliseconds. Kama program iko very complex, then scan time inaweza kuwa a bit late kuliko program ambayo it's easier to go through. So yeah, we have a type of PLC CPUs. Tuliangalia types of PLCs, tukasema kuna compact PLC na modular PLC, ambayo tusema compact yenyewe iko very limited in expandability but it's cheaper, zinatumika kwenye easy ama simple automation. Lakini tukasema kuna modular PLC ambazo zenyewe they are expandable but they are expensive, they require more space, more wiring, but they are more useful for a complex automation fields. So now we have types of PLC CPUs in reference to the types of PLCs. So we have a fixed CPU. So a fixed CPU is actually found in compact PLCs, integrated with the memory and the I/O interfaces. So inatumika for small scale applications. And then we have a modular CPU. A modular CPU is used in rack-based PLCs. Amazon is a modular PLC, very expandable. Na ina allow CPU upgrades for higher processing power. So you can upgrade the CPU for a higher processing power according to the needs and demands of your industry. So the modular CPUs are suitable for large industrial automation systems. Bravo! I hope you have captured plenty from this presentation. You're doing great. Keep moving forward. So until the next lesson, for now, ciao.